I didn't hear what you said, Jennifer, but
I said it's not,
it's not newtons, okay. Think about what you multiplied.
the meters and the.
So the units would be,
Newton times meters?
yeah,
J.
newton meters. Meter newtons if you want. Typically newtons comes first. If you do put the meters first, please make sure the dot between them is there.
They're not squared.
Pardon?
They're not squared.
No,
No.
just, each one is a meter times a newton.
Okay.
So, not too far off. I'm pleased with our fake numbers. So now, let's add a twist to it. I'm gonna take the same beam. This time I'm gonna add an unknown mass to it. So the center of mass is at, so that's 0 meters, and then at 0.199 meters, that's the spring. The middle is at 0.501 meters, and then 0.799, then at 0.799 meters. We have another string here, so pulling up. I'm gonna put an unknown mass here, hanging. Let's pick some somewhat reasonable numbers. So let's make this 0.72 newtons, and I need to give a location 0.90 meters. Let's see what this takes us. So we can figure out what the unknown mass is two different ways. One, we can do it from just plain up chapter 2 forces up equal to forces down. So we'll start out with that one, see what we get, and then we'll do it with torques. I know the total force should be 0. So 0.72 plus 2.14 minus 1.1238 minus the weight of the unknown equals 0. So I just added the forces up, these are subtracted, I'm adding a negative. So plus a negative, plus a negative. So doing this, I'm not finding the mass immediately, I'm finding the weight first, and then I'll find the mass. I know that the sum of those is going to be the opposite of, that will be the weight. So the weight of my unknown, 0.72 plus, actually I'm going to do it slightly differently. I'm going to put a plus there. It's going to closer mimic the lab. I will get a negative number, and that makes sense because that force is downwards. So my weight of the unknown is going to be, or at least the force due to gravity is going to be 1.1238 minus 0.72 minus 2.14, bringing these all over to the other side. And what do we get? Negative something.
Negative 1.7362.
1.7362. Units?
Meters? No.
Yep, somebody just said it. So that is this force of the weight. It is downwards, that's what the negative sign is telling us. So the magnitude of the weight, or the magnitude of the force due to gravity, is just the absolute value of that, 1.7362 newtons. And I know that's equal to mg. So if I want to find the mass, well, I just divide by g. So my mass is going to be 1.7362 newtons divided by 9.798 meters per second squared. We end up with point something. 0.1 something. 0.179.
Point 177 4285. I didn't know if you wanted all of it.
I was not necessarily expecting that, but units would be cool.
Newton meters per second squared?
Nope.
No?
If we're going by the units that we have there, we have newtons divided by a meter per second squared, which is the same as a newton times a second squared per meter, which would be a newton second squared per meter. But there is a one-word unit for it. Don't make Monica play by herself. What did we find? Somebody just whispered it.
Mass.
Yes.
Oh, no.
So what units would you expect? Yes. Kilograms. But if you said Newton second squared per meter, oh, that's not wrong. All right, so we found the mass using just the plain old chapter 2, forces up equal to forces down. But now we can use torque. Woo. And we can pick any point that we want, because again, it's not moving at all, so there is no natural axis of rotation. So we pick anywhere. We picked the left-hand side this time, let's do the right-hand side. I'm gonna have 1, 2, because there's a weight acting down here. I have 1, 2, 3, 4 forces. So I'm gonna have 4 torques. And the sum should be 0. So go from left to right. This is 0 over here, this is 1 meter over here. So the moment arm to my 0.72 newtons, what is it? Again, it's a vector from here to here. What is my moment arm?
You don't do 0.90 times 2.14? No?
0.90 times 2.1. What?
Oh, no.
I have 4 forces here, I'm just trying to find the torque. I'm finding torques right now.
Mhm.
So that, starting from left, going left to right, the torque from this one is gonna be R times F. What is R? What's the magnitude of R? What is that distance? Or how would you find it?
Would you combine the three lengths?
Do.
No.
Alright, so I've got a beam here. I'm trying to find the distance to here. I know this distance is 0.199 meters. I know the distance of the whole length of the whole thing is 1 meter. And what I'm asking is, what is this?
.801.
Yeah. So my torque, negative 0.801, because I'm going in the negative direction, times my force of 0.72. All right, now the middle. What is the moment arm for my weight? In other words, the length from here, or the vector from here to here.
Is it the 0.1772?
0.1772, how'd you get that?
Oh, it's the
Oh, no, I'm looking for, what is that from here to here? If everything were done perfectly, we'll ultimately end up with that as our mass, but we're not there to find mass yet. We have to get the other stuff done. So, the vector from here to here. How'd you get 0.801?
I subtracted .1 from .199.
So now, instead of 0.199, we have 0.501.
So .801 minus .501?
Say that again?
.801 minus .501? No.
No.
Is it the 1 meter minus the 501?
Yeah, that would get you the magnitude.
0.499?
Yeah. But it's going to the left, so negative 0.499 times the force, which was 1.1238. Plus, next one. I need to know what the magnitude of this vector is, the moment arm for this one. So, vector going from my axis to here.
.1? Is it 1 minus .9?
No, it's 1 minus 0.799.
I don't know why I'm getting confused with that.
Going left to right.
.201.
Times points, times 2.14. Plus, the last one, I don't know what the weight is, but I'm gonna try to figure it out. But the moment arm, again, a vector going from here to here, is,
1 minus .9?
yes,
Okay.
negative 0.1 times W. Whatever the weight is equals 0. So what we're gonna do is we're gonna figure this out right here. It's the sum of all the torques of the known stuff that we have. So what is that equal? It's gonna be negative, I know that.
And I'm not adding the negative .1.
Correct. You're doing
Ignoring.
just those three terms.
I got negative 1.567.
else get the same thing? Okay, so that's equal to 0.1 times the weight, so the weight would be negative 15.67. If you divide by 0.1. Newtons. So the magnitude, that is actually the vector weight, it's downwards, that's the negative sign. But to find the actual mass, we do 15.67 divided by 9.798, and that should tell us the mass. And we're gonna get a distinctly different answer than what we have right there.
1.599305981.
Did I nail it? Is that what you said?
9930591.
So we did two different methods, came up with two different values, and the reason why they are so far off is because I made up numbers here. But this is the basic technique. If I had chosen a different pivot point, I would have gotten a different answer actually.
Can we go through, I think, subtracting the measurements from the whole length of the beam? Like getting to that equation,
All right, so
just like,
I'm gonna look at it slightly differently.
okay,
My moment arm is a difference in position. It's from my axis to where the force is applied. So X final minus X, minus sign there. So I'm starting at the pivot point, so wherever my axis of rotation. And final, that's where the force is applied. So if I want to figure out what my moment arm is, so for instance, the 0.72 newtons over there on the left-hand side, it's 0.199 minus my axis, which was 1.
okay,
So you get to that. My weight is at 0.501, so this is 0.501 minus 1.
mhm,
And then 0.799 minus 1.
and how do we know the length of the whole beam was 1 meter? Because
I gave it to you.
oh, you gave it to us?
Yeah.
Oh, okay, because I was looking at this and then that, and I'm like, how do we get 1
It's,
on the beam?
because in the lab, you'll actually use a meter stick.
Gotcha, okay,
Now, in general, if I had chosen this to be the pivot point,
uh-huh,
instead of that or this, well, this moment arm would be 0.199 minus 0.501.
okay,
The negative's gonna come out of it because I'm going to the left.
to the left,
Over here, well, that moment arm would be 0. Moment arm of this one, 0.799 minus 0.501. I get a positive number, I'm going to the right.
mhm.
And then the last one, 0.90 minus 0.501.
And for us, we had negative 0.801 and negative 0.499 because we were going, I thought we were going to the right because that's where the axis of rotation was, right?
For this right here, I said, let's make this end over here the pivot point.
The pivot point.
So
Okay.
all my
So
moment arms are
everything to the left, okay, is negative. Okay. That makes more sense.
It's like, this is the origin now,
Mm-hmm.
and the positions of each of the others.
To the left or
To
negative.
the
So
left.
if it was in the middle, then those would be negative and then those would be positive.
Absolutely,
Okay.
yes.
Okay. Gotcha.
And on that lovely note,
Where do you want us to put our master set?
there's a.
Is there already a?
Oh. Tests. I can give it to you Thursday if you don't want to hang around. stop this before I accidentally